Hi, so welcome again another class on transportation problem. Today I shall explain. So our feasible solution, say when we test it up for optimality, then we have realized that the present present basic feasible solution is not optimum. Then what is to be done? Then how to modify and get a new modified distribution, and so that that solution is better than the previous one. So for this purpose I have chosen again a 3 by 4 transportation problem. That's what we have here, and I have obtained distributions, so like this, what you see here, and the associated transportation cost I have calculated, that happens to be 251. Now I have to check whether this feasible solution is a basic feasible solution or not. For that purpose I have just counted what is the number of basic cells. 1, 2, 3, 4, 5, 6. 6 basic cells are there, and m plus n minus 1 is also 3 plus 4 minus 1. That is also 6. Therefore this is a basic feasible solution and eligible for optimality test, and therefore go for optimality test. Okay, the first step of the optimality test, which I had already explained, and I have written Cij matrix of only basic cells, and accordingly then I have assumed u1 equal to 0. Then I calculate what is v1. u1 plus v1 is equal to 6, like that. 6, 9, this, all these values I have calculated. Cij of only basic cells, and calculation of ui and vj assuming any one of them as 0. Then the second step of the optimality test, what is called as Cij dash of only non-basic cells. Now all those basic cells where I have value, I have marked them as cross. Now they are they are all basic cells. Now I am supposed to calculate for non-basic cells. So now this value 0 plus 8, this value 0 plus 11, like that I have calculated. And now I have calculated what is called a cell evaluation matrix. This is nothing but this entry. Again, this is only for non-basic cells. This value is nothing but C13. Say for the cell first row third column, this value is C13 minus C13 dash. C13 is here, that is 5, and C13 dash is 8. 5 minus 8 minus 3. This C14 is 2, C14 dash is 11, like that. This is minus 9. And for other cells I have calculated on the same way. And because of a negative entries, there are two negative entries, and because of any negative entry, therefore this solution is not optimal. Immediate conclusion. Then I have to, as I know that this is not optimum, this solution is not optimum, C equal to 251, this associated plan is not optimum. Now I have to improve it. I have to modify the present distribution and improve it. What should I do for that? Okay, so therefore first step is identify the most negative entry. So in this case there is only one such case, and sometimes we may have more than one also. There may be tie. In that case, break the tie by randomly choosing any one. The most negative entry is minus 9, and that corresponding cell is 1, 4. Choose that cell. So this is the cell what I have chosen, and immediately I assign a sign, what is called as plus sign. Now starting from here, I have to draw a loop using only the vertical line and horizontal lines, such that all other corners of that loop happen to be basic cells. Now wherever I have put cross, what you can see here, all these cells are existing basic cells. Now this is the starting point. Now to draw a loop, I need to draw a vertical line. I want to draw only vertical line, and this is the only line what I need to draw, because this is a basic cell. This is where I have to end. There is no other basic cell, therefore I can't draw it. Now I have to draw a horizontal line, and this is the only basic cell here, and therefore, so this is where I have to go and end it. Now I have to draw a vertical line. I have two choices. So if I start from here and end here, now I have to draw a horizontal line, and the only possible horizontal line is this. Then further vertical line is not possible because there is no basic cell. Therefore, don't stop here and go further. And then from here I have to draw a horizontal line, and I can see my starting point and I can come back. This is how the loop is drawn. The loop is always guided and you have a unique loop, and there is no problem for drawing loop. So now after drawing the loop, then for this loop, for every corner we have to assign signs such that adjacent, say if one corner is plus, then the adjacent one is minus, then plus, like that. So I start from here, this is already plus, then I shall put this as minus, then this as plus, and this as minus. Okay, so loop, this is over. Then wherever you have minus sign, no, there are two cells. One is this cell, that is 1, 2. Another one is this cell, that is 3, 4. So wherever you have minus signs, what is the present Xij value for these things? That I just check it. Okay, so for this 1, 2, go back to your 1, 2. Okay, this is a cell, this value is Xij, for that is 5. And for cell 3, 4, the value is 7. So among this 5 and 7, the minimum value is 5. So therefore I have chosen what is the minimum Xij at negative sign cells, that is 5. Now what is going to happen is the new solution shall have the modification. Okay, there will be a modification in the distribution by units 5, by quantity 5. Okay, so how to achieve that, how to get that? Wherever I have plus sign for the cell, so that cell shall add this 5, whatever is the existing Xij plus 5. And wherever I have minus sign, then whatever the present Xij, that I have to subtract this 5 units. And the cells which are already basic cells, but there is no sign for that, and in that case I am not going to change the distribution. For example, 1, 1. This is a basic cell. What is the value? Present value, present Xij, it is 10, and it is not having any sign. Therefore, this will continue to have 10 units. The second one, it is minus. So right now it is minus, this is 5, and it is having minus sign. Therefore, 5 units have to be subtracted. Therefore, this becomes 0. Then the next, third one, and it is not having any sign, plus or minus, and no sign, and therefore there is no change. It is already having 0, and 0 will continue. The fourth one, 1, 4, it is having plus. What is the present Xij? It is 0. There is nothing. Therefore, it is 0. 0 plus 5. Therefore, the new solution shall have distribution of 5 units. For the second row, the first cell, again there is no sign. There is no sign. And Xij is 0, therefore it will continue to have 0. And second row, second cell, right now 12, and here there is no sign here, therefore there is no modification, it will remain as 12. Second row, third cell, it is 8 units, and this is not having any sign, therefore it will remain as 8. Second row, fourth column, there is no sign here, and it is 0 already and earlier, and since it is not having any sign, it will continue to remain as 0. Third row, first column, okay, 0 and no sign, therefore remains same. Third row, second column, so it is 3 and it is having plus sign, 3 plus 5, this becomes 8. Then third row, third column, so it's 0 earlier, and now also there is no sign, therefore it will remain as 0. Third row, fourth column, so 7 units in the, and it is having minus sign, 7 minus 5, this is 2. So this is my new distribution plan, and accordingly you can easily write down what are the Cij values. For example, this is 6, this is 9, 5 and 2. These are Cij values what I am writing. This is 8, this is 4, 3 and 6, 7, 6, 5 and 8. You can easily calculate what is the cost. The cost happens to be associated with this plan is 206, which is better than earlier one was 251, and therefore this is the new solution. So again, this may not be the optimum solution, therefore it is again has to be subjected to optimality test. If it is optimum, fine, that is the optimum solution. If it is not, then again we have to perform, okay, similar operation has to be done and to get a new modified better solution and go on till we reach the optimum solution. Thank you.